So for this question, we're talking about externality and trying to find equilibrium within the externalities. So the problem question, or the practice question, you'll see a graph much like this. So you'll see a list of people on the left and a list of people on the right. Right? The people on the left have a maximum price willing to pay. In other words, they're demanding something. It's showing you some equilibrium price, and yours might be different, and then the people on the right are the suppliers. And they have a minimum acceptable price. So what's the minimum price they're willing to sell a product for? So one of the first questions you'll ask is to find the equilibrium quantity, right? So given the equilibrium price of $8 in this instance, what's the equilibrium quantity given the data above? Well, to determine the equilibrium price, we begin by comparing the highest willingness to pay with the lowest minimum acceptable price. A is willing to pay 13, and T is willing to sell it for 3. Will they make a transaction? Yes. Because if they're selling it at $8, it's less than their maximum willingness to pay, and it's more than the minimum price willing to be accepted. For B and U, right, 12 again is more than the actual equilibrium price, and it's more than the minimum acceptable price of $4. Then we go on to the next trade, right? And this keeps going on until the maximum willing to pay equals the minimum acceptable price. When they reach each other, surplus will be 0, and the equilibrium quantity will be reached. In other words, maximum price willing to pay is $8. Actual equilibrium price is $8. Yes. Again, minimum acceptable price is $8. The actual equilibrium price is $8. Yes. So all these transactions will occur. So yes, 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 and yes. Now, how many transactions actually occurred? 1, 2, 3, 4, 5, 6. So the equilibrium quantity given the above data is 6 bags of whatever product this is. Now, what if, right? I think they're saying instead of oranges, right? The data in the two tables dealt with a public good, like a fireworks display. If all the buyers free ride, okay, so in other words, free ride, what's the quantity supplied by private sellers? Well, if every buyer free rides, then the quantity supplied will be 0. Everyone will try to pay a price of 0, and therefore, because there is no profit to be made, supply will be 0. Now, assume that we are back to talking about oranges, right? A private good. But the government has decided that tossed orange peels impose a negative externality on the public that must be rectified by imposing a $4 per tax bag on sellers. Okay, so a $4 per bag tax on sellers. Well, what's the equilibrium price? If the previous equilibrium price was $8, and now they're imposing a new $4 tax, it's going to increase the equilibrium price. Right? So producers must now pay an additional $4 on top of production costs. This implies that the minimum acceptable price for, say, T is now $8. Because 3 plus 4 is equal to, or $7. 4 plus $4 is equal to $8. 5 plus 4 is equal to $9. 6 plus 4 is equal to $10. Plus 4 is equal to $11, and plus 4 is equal to $12. Okay? And so on, right? Comparing this new minimum acceptable price schedule with the original maximum willingness to pay, we can find the new equilibrium quantity using the same process as in part A. If this is the optimal quantity, then the market was overproducing. So we'll see. Okay, so for 13, so let's try and determine the new equilibrium quantity and price. So at $13, right, would they trade with the $7? Yes, that would occur. At $12, he's willing to pay $12, they're willing to accept $8, that transaction would occur. Right, $11 and $9, that transaction would occur. $10 and $10, that would occur. These would not. Therefore, you can see the new equilibrium falling here at the $10 mark. Okay, so the new equilibrium quantity is 1, 2, 3, 4. So 4 bags were produced. And comparing it to the previous question of how many bags were produced, previously it was all 6. Now we're at 4. Therefore, right, there were 2 bags which were being overproduced before if we impose this new externality onto the data.